Thus far, we've looked at what is acceleration. Acceleration is the rate at which you change velocity. That's your formula. The units, meters per second per second. We looked at how this can also be expressed as meters per second squared. There are 3 ways that you can change your velocity. So if we time those changes in velocity, we have acceleration by speeding up, acceleration by decreasing the velocity, and acceleration by changing direction. And of course, the key is timing all of those events. We've looked at how your accelerator pedal, gas pedal, can be an example of acceleration if you time how fast it takes you to increase your velocity. If you time how long it takes you to change direction, that can be acceleration. And if you time your slowing down, that can be acceleration as well. Letter E, describing the acceleration of an object moving in a circular path at a constant speed. Despite having a constant speed, you are accelerating because you're changing direction. Describe the velocity of an object with its acceleration is 0. An acceleration of 0 means your velocity could also be 0 at rest, or you're maintaining a constant velocity, moving without any acceleration by not going faster, slower, or changing direction. Now we're going to look at this quantitative piece here. All right, what is the acceleration of a car moving along a straight line which increases the speed from 0 to 100 kilometers per hour in 10 seconds? We want to use our guide steps. These are located on all page 0 of your study guides. So the first thing we do is jot down all of our steps, or all of our numbers. And so the acceleration moving, there's a number 0. And we have 100 kilometers per hour. So 100 kilometers per hour. And 10 seconds. So 10 seconds is a time interval. 100 kilometers per hour, a velocity. And 0 speed, okay, kilometers per hour as well. We are safe to assume 0 kilometers per hour. And since we increased from 0 to 100 kilometers, that's our initial velocity, that's our final velocity. So that's the given. Our unknown, what is it we're looking for? What is the acceleration? And surprise, surprise, a page introducing the topic of acceleration. We have the unknown. Identify, arrange a matching formula for what you are given. So acceleration is the rate at which I change velocity. Velocity final minus velocity initial, and we have the whole time interval. So acceleration, I have velocity final, 100 kilometers per hour, minus 0 kilometers per hour, divide by my time interval of 10 seconds. Acceleration, I have 100 minus 0, 100 kilometers per hour, divide by 10 seconds. 10 goes into the 110 times, so kilometers per hour per second. Which means for every second, I had an increase of 10 kilometers per hour. My velocity increased by a rate of 10 kilometers per hour every second. So 10 kilometers per hour per second turned out to be the rate. Now with this evaluation step, are the answers in the units reasonable? It's kind of hard to gauge, as we tend not to think of acceleration rates really, as we have 2 dimensions of time. But going faster by 10 kilometers per hour every second might just be doable by a car. Sort of reasonable. And one of the ways you can think about your rates in metric terms is in your study guide kinematics of the page Catch the Wave. There's a chart, had tsunami speed, softball, baseball, bowling ball, things of that nature. Kind of get your head around this idea of how fast is 10 meters per second. Item 2, a truck increasing its speed from 50 kilometers to 60 kilometers per hour, and a bicycle goes from 10 kilometers per hour in the same time. From 0. I should clear that off a little bit there. It goes from 0 to 10 kilometers per hour in the same time. How do the accelerations of the truck and bike compare if traveling in a straight line? Okay, so given. Jot down all the numbers. So for the truck, this is my beautiful truck, and it goes from 50 to 60 kilometers per hour, and it does so in the same time as our bicyclist. Let's not even attempt to draw a bicyclist on there. Maybe that's the bicyclist leaning over. Goes from 0 to 10 kilometers per hour, and those happen at the same time, or in the same amount of time, rather. Compare their accelerations. So acceleration is the rate at which I change my velocity. The time is being considered the same, so really what I want to think about is the change in velocity, since the time is the same. Well, my change in velocity for the truck, change in velocity, I'll just put T for the truck, is 60 minus 50 is 10 kilometers per hour in whatever amount of time. And the change in velocity for the bicycle, 0, is 10 kilometers per hour in that same time interval. So to answer the question, how do their velocities, or their accelerations compare? It's the same. Their accelerations are both 10 kilometers per hour per whatever unit of time. So their accelerations compare by being equal. And the final item on page 4, acceleration. We have an Indy 500, so Indy 500 car. Its velocity goes from 4 meters per second to 36 meters per second in 4 seconds. So that's the time interval. And which one is the starting? Increases from 4 to 36. So this is the initial velocity. That's the final velocity. And here you might see from Physics A why Indy 500 is not quantitative. Yeah, it's a number, but it's a name of a race. So it doesn't help us in our calculations. So those are the givens. Find the unknown. All right, we are trying to solve for, hey, what's the acceleration? And, well, let's just be consistent here. Acceleration is the number we're looking for. And it says average acceleration, and for physics, you can always assume that we're talking average acceleration. The other type of acceleration you could consider would be instantaneous acceleration, and that's more focused for AP Physics, AP Calculus. Back to our work at hand, identify the problem or the formula in the problem to use. Acceleration is the rate at which we change velocity. Changes in velocity, V sub f, or final velocity minus initial velocity, and a whole time interval they give us of 4 seconds. And this change in velocity, 36 minus the 4, so 36 meters per second minus 4 meters per second. Continuing, acceleration is 36 minus 4, 32 meters per second, and divide by 4 seconds. 4 goes into 32 wholly 8 times. My units, meters per second. Now the question of measurement accuracy. How many decimal places do I put? Remember, you can never be more accurate in your answer than the least accuracy you started with. I have 1 decimal place there. And I didn't copy this down from the problem correctly. There's a decimal place there. So I have 1 decimal, 36, none. I look over here. Yep, there are no decimals here. So I can't have decimals in my answer because I didn't have decimals to begin with. So it would be 8 meters per second, which pretty reasonable, especially for Indy 500 vehicle.